So welcome out everybody tonight. I think a lot of times when people think about AI and what you've heard about AI, maybe you've heard about it on the radio. It's been on CNBC almost relentlessly over the last several months, or maybe you've heard about investing in NVIDIA chips or maybe AMD. That's been all about the technology. Tonight, we're going to talk a little bit about the society ramifications, the societal ramification. What does AI mean to you? You may not be a computer science major. In fact, I'm not a computer science major. Probably nobody on the call tonight is. So on some level, you're like, well, how does AI affect me? So I got a question for you as we get started. And that is, what do Antifa, Black Lives Matter, Occupy Wall Street, and Trump voters all have in common? Just give that like 2 seconds worth of thought. What do they have in common? Because you would think these are all groups that really don't have much in common and don't like each other. I would argue that each one of those groups is a group of people who are saying that the economy, that the society that's been built for me doesn't work. Antifa is blaming white supremacists. Black Lives Matter is blaming the white power structure. Occupy Wall Street is blaming the bankers. Trump voters view every foreigner who is taking American jobs as the enemy. And the reality is they're all wrong. So let me give you a different way of thinking about that. And that is that Warren Bennis said this quite some time ago, but I'm going to paraphrase it. He said that the factory of the future will have only two employees, a man and a dog. The man will be there to feed the dog, and the dog will be there to keep the man from touching the equipment. And how to think about that, right? Some of you probably maybe as old as I am, you may have remembered, this is not a discussion that's new to humanity. When I was a kid, it was man versus the machine. Paul Bunyan and Joe Maffaw. Joe was going to have sort of a chainsaw, and Paul Bunyan was going to use his axe. And this was in 1958. Lumberjacks were worried about automation taking their jobs. Well, 40 years later, in 1997, about 30 years ago, IBM's Deep Blue beat Garry Kasparov, who was arguably the best chess player in the world, 2 games to 1 with 3 ties. And then 14 years after that, in 2011, IBM's Watson crushed the best Jeopardy players in history. You can see the scores there on the slides. In 2016, as we're getting more recently than that, Google's AlphaGo defeated a man named Fan Hui, who was a lower-ranked professional player. And in March of 2016, it played Lee Sedol, who was the world champion in Go, which is a game that's considered to be infinitely more complex than chess. And he was of the highest rank, beat him using strategy that Go masters, people, human beings, described as beautiful. So the AI had not only progressed, it was progressed to the point where it could beat the best players in the world at the most complex games and do it in a way that people marveled at. But it isn't just fun and games, if that's what you consider Go to be, but computers now create art. So what you can do now is you'll see sort of famous painting in the upper left-hand corner, and in the other 3 panels are variations of that art created in the style of other artists. So maybe Van Gogh's Starry, Starry Night in the lower left-hand corner, right? Or Munch's the Scream in the lower right-hand corner. So computers can now create art. And for those of you that aren't familiar with it, I'm gonna give you some resources to look up where you can access this for yourself. It's not going to be just about me talking about this. It's about, after we're done tonight, hopefully you'll have the ability to go and find some of these resources yourself and experience it yourself if you haven't. Use it yourself if you haven't, because the first step maybe is hearing about it, but the second step is using it and getting familiar with what I'm talking about. So about 10 years ago, actually a little bit more than that now, 13 years ago, at the University of North Carolina, or Duke University rather, they entered a poem that had been created by artificial intelligence. The poem was known as Bristlecone, or titled Bristlecone. You can see the poem there, and it won an undergrad poetry competition. Now, for a long time, people in artificial intelligence had something called the Turing test. It was first theorized by this guy named Alan Turing. If you saw the movie The Imitation Game, it was all about Alan Turing's life and the work he did breaking codes and creating computers to break codes during World War II. But he said he had the foresight back in the 1940s to say there would come a time when computers would be able to interact with humans, and humans wouldn't be able to tell whether they were interacting with a human or interacting with a computer. And people believe this may be the first point in time where a computer could pass the Turing test. That is, you could read that poem and not tell that it was made by artificial intelligence. You might think it was just made by some undergraduate in school. Well, so we talked about art and we talked about poetry, but computers are also now programming their own chips, designing their own components, building their brothers and sisters. This is where it gets a little bit weird. I mean, Elon Musk describes the gigafactories as the machine that builds the machine, right? And this is sort of where I got involved with artificial intelligence about 11 years ago. I worked on a program for NASA called NASA iTech, and we were chartered to go out into areas like Silicon Valley and Austin and the Consumer Electronics Show and find startups and people that had new technologies that NASA might not be familiar with, that they might need 10 years from then. And one of the big things that the big problems we were working on was this idea of autonomy and probe autonomy. So I want you to think about this for a minute. When we send a probe to Mars, it takes about, depending on where Mars and the Earth is, it takes about 14 minutes for the signal and instructions to get to Mars and tell the probe what to do. And then it does it and it sends the response back to mission control. And that round trip takes almost a half an hour, 14 minutes there, 14 minutes back, plus the probe's got to do some things. And that's barely workable at Mars. Well, the next set of probes that NASA planned to send out was to Saturn and Jupiter, to Io and Callisto. In fact, one of the probes they want to do will go out to Io. It will drill into the ice, drill a mile through the ice, and then send a probe down that mile deep hole into the ocean below. And that's so far away that you can't give the probe real-time directions, first. And second, you want the probe to have a certain amount of curiosity. I'll tell you a story real quick about what they call the Genesis Stone. The Genesis Stone was found by Apollo 16, I think. It was the last Apollo mission to the moon. And by happenstance, on that mission, we sent a geologist for the first time. Before that had been fighter pilots and other folks, other types of scientists. We'd never sent a geologist. And on the last extra vehicle mission, they're out walking around, and the geologist, out of the corner of his eye, he sees a stone. He says, "That looks unusual. It shouldn't be here." And he picks it up as part of their sample kit. He brings it back and he finds out this is the oldest stone they've ever found. It's over 4 billion years. They call it the Genesis Stone because it's so old. And but for the fact that he'd been a geologist, but for the fact that he'd had sort of the curiosity and the training to say, that doesn't look right, I should pick that up, we would have never had access to that stone or what they found because of it. So when you send a probe to Saturn or to Jupiter and you can't communicate it in anything that's meaningfully real time, it has to have enough curiosity, it has to have enough knowledge that when it sees something in the ocean under a mile of ice, to say, that doesn't look right, I should investigate that, right? And that's a whole different level of intelligence than any probe that NASA's launched to this point, right? So what does all that mean? And so we're going to modify Warren Bennis's quote a little bit. What it means is the factory of the future will have only equipment, right? Well, if the factory of the future only has equipment, that has profound implications for our society. Because for as long as there have been people and recorded history, we have defined ourselves by what we do for a living. Like if I come to you and I say, "Hi, my name's Tom. What do you do?" You don't say, "Well, I ski and I garden and I like to go for drives." You understand implicitly that that means what do you do for a living, right? That's how we define ourselves. I'm a carpenter. I'm a computer scientist. I'm a whatever. Well, if you're in a society where, say, 50 or 60% of the jobs have been taken by computers and artificial intelligence, how do we start to think about who we are and what value we bring to society? And that's really what we're going to talk about tonight. That was a long-winded, long-term introduction. You're like, Tom, you're 20 minutes into this, and we're just finishing the introduction. I promise we'll try and finish on time. So we have certain outcomes to think about. We have this idea where robots are our friends, somewhere between Star Trek, where there's no money and technology exists and allows us to explore the galaxy and achieve self-actualization as a species, and Wall-E, where computers meet all of our needs, and if we aren't careful, they allow us to sink into the lowest forms of sort of laziness and debauchery, right? On a worst case scenario, robots are our masters or our enemies, somewhere between the Matrix, where we serve as biological batteries, and Skynet, where we fight a war of extinction. So we put that on the Boston Consulting Group Magic Quadrant, where machines are our friends on the left-hand side, more or less, and machines are our masters, more or less. And it shouldn't escape you that really only 25% of those outcomes is good for people. The other 75% don't end well. So part of what we're going to talk about tonight is maybe how you think about how to make it end well for you, because I understand this is sort of building blocks. It's sort of, and one of my good friends, Andrew Cohen, was a speaker for you guys just a little while ago. He was talking about, I think, finances and investing and financial preparedness. I'm going to talk a little bit about maybe career preparedness in an era of AI. And if not for you, maybe for your kids, because I'm of an age where I'm on the backside of my career, retire in a few years, but my kids are in their late 20s and early 30s, and how should they think about this? And so I want to give you some ideas about how to think about this tonight for your kids and how they might do career selection, and think about career selection, what career choices might be more durable in the face of AI, and what career choices might be less durable and more easily replaced in the face of AI. So all that's way in the future. Now we're going to diverge here for just a little bit, and then I promise we'll come back. But free market capitalism can be defined a number of ways, but one way to define it is a system of economics where large entities compete to establish barriers to trade, lobby government to help them hurt other businesses, control a country's political outcomes through financing its politicians, extract maximum profits from labor and other inputs, deceive customers about their products, and prevent other businesses from getting started or otherwise competing. Now, I'm a free market capitalist. I wouldn't necessarily ascribe to that, but there are some people that might define free market capitalism that way. I might define it as a self-regulating system of economics where consumers and producers, each acting in their own self-enlightened best interest, allocate products and services at the lowest cost and with greater variety than any other system. But what happens when robots create the lowest cost goods with the highest quality? And we've been seeing this since about 1980. Assembly line workers have been replaced by robots in many companies. Bank tellers have been replaced by ATMs. Cashiers have been replaced by self-checkout. Fast food clerks have been replaced by kiosks. And those are mostly jobs where you could make a living with your IQ could be less than 100. But it's predictable that we're going to lose other jobs like blueprint readers, engineers, and architects. Jobs where your IQ could be between 100 and 110. Or where you could be a surgeon or an anesthetist or other expert. Jobs where you could have an IQ between 110 and 130. So I'll give you one example of that, because you might think, doctors, how could doctors be replaced by AI? I'll give you two examples, in fact. It is quite likely today that if you get a X-ray or an MRI or a CT, that it gets shipped to India, to be read by a radiologist in India. Because they'll work for, I don't know, a third to a half the price of a radiologist in the United States, and they do just as good a work. And because once the picture's digital, it's easy to ship around the world. So they had, when we wrote this book, I, Frankenstein, my co-author, Jose Mori, was working with IBM Watson. And they did a test in San Francisco where they gave IBM Watson a little bit fewer than 1,000 X-rays to read. It was like 980 X-rays to read. And in reading those X-rays, IBM Watson found 3 previously undiagnosed cases of cancer for people, and was proven to be better at reading the radiologists than the radiologists themselves. We're going to come back to that story, because this idea of then how do people in India compete with AI in the United States? It's a really interesting discussion. So I want you to look at this chart, and I want you to notice some things. So this is a chart of what's called the labor force participation rate. And the labor force participation rate is not the same as the unemployment rate, but in my estimation, it's really what matters, because a lot of times we get focused on the unemployment rate. But whether you're talking about Jimmy Carter, Ronald Reagan, George Bush Sr., Bill Clinton, that trend was up and to the right over time. But since George Bush, that trend has been almost uninterruptedly down and to the right. So you have to ask yourself, what kind of tipping point existed around the year 2000, where we went from creating an economy that needed a higher and higher percentage of the society to participate, to one in which we could produce the same amount of products, goods, and services, actually an increasing number of products, goods, and services, because since about that time, since 2000, the GDP of the United States has essentially doubled, and we've doubled it while employing fewer and fewer of our people. Now, you could say, well, COVID had an outsized effect here, and it did. And during President Trump's presidency, the labor force participation rate improved marginally, but in general, it's been down and to the right for the better part of 2 decades. So in June of 2023, there were 135 million full-time employees. Keep that number in mind. We're going to come back to it. 135 million employees. So here's what's going on in terms of computers. Moore's law, which you might be familiar with, it's gotten a lot of press over a long time, says that the processing power of a microchip doubles every 18 months. That means computers become faster, and the price of a given level of computing power gets cut in half every 18 months. But there are other laws that are, if anything, more powerful but less well known. One is called Gilder's law. Gilder is a famous technology and investment advice person. He's an author. He says the total bandwidth of a communication system triples every 12 months, and new developments seem to confirm that bandwidth availability will continue to expand at a rate that supports Gilder's law. And then there's Metcalfe's law, attributed to Robert Metcalfe, the originator of Ethernet. He said the value of a network is proportional to the square of the number of nodes. So as a network grows, the value of being connected to it grows exponentially, while the cost per user remains the same or even goes down. That seems like a lot of really complex way of saying it. So what does that mean? Let's think about it in terms of people. In terms of people, for you to have a job, your position must create more value for the business that it consumes in expenses, right? If I have to pay you $1, you have to make me at least $1.01, or I may as well not be employing, right? And that's a really harsh reality. People don't necessarily think about it. That's sort of, some people might say you're exploiting the worker, but that's the deal. If I'm going to have a company where I have a job, the employee has to create more value for the business than they consume in expenses. It's just, that's the way it works. And so in an efficient business, you'll always be replaced by lower cost alternatives, such as outsourcing to China or India, whether it's radiologists or whatever, or robots. Therefore, to have a job, you must always create more value than you consume. But the cost and capability of automation are constantly improving the hurdle to create more value than automation. And that's rising at a fantastic rate. So remember, I showed you, from 1980 to about 6 years ago, we could automate jobs where people could do them with an IQ less than about 100. This would be like bank tellers and so on. But now it's more people, even jobs where even people who are more intelligent, those can be replaced as well. And that only gets worse over the next, say, 5 to 10 years. So now let's broaden it back beyond artificial intelligence, or what we might call machine learning here in the second bullet point. And by the way, let me define myself here tonight. So there are different types of artificial intelligence. There's what's gotten a lot of press recently are large language models, but there's also neural networks, machine learning. These all fall under the sort of the idea of artificial intelligence. And yet there are, say, 6 or 7 other areas of technology that are also impeding or imposing on jobs and the economy. Blockchain, cryptocurrency got a lot of press over the last 15 years or so. But there are jobs that are directly affected by blockchain as it gains traction. Mobility, that is the ability to use wireless and large networks to move data around. Big data, that is large data sets that can be analyzed quickly by the amount of powerful computing power that we have now available to us. Drones and robotics, the ability to autonomously move people and things from place to place. The cloud, that is the ability to move questions and information to central locations where they can be processed by huge amounts of computing power. The Internet of Things, the ability of your thermostat in your car to be connected to the network. And I don't know if you guys have it, like an app on your phone where you can check the contents of your refrigerator or the temperature of your house. These things all exist. And the social web. Not me saying this, but a agglomeration of various groups estimate that 47% of jobs within 20 years. Remember when I talked about 135 million jobs? Roughly 50% of about 60 million people would be out of work, right? So then we have to think about how is society built to cope with that level of unemployment. I gotta on my screen get something out of the way here real quick. This is from Forbes relatively recently. Artificial intelligence and other economic drivers will result in 83 million job losses over the next 5 years. They're talking about across the world. I'm talking about just United States over 20 years. But according to the World Economic Forum and Forbes, the job loss is estimated to be profound. And while I've heard some people talk about it, I haven't heard our politicians starting to discuss what to do about it. Right? So what if there were just 8 areas of technology and each was just as likely to have as profound an impact on jobs and the economy? We're going to focus tonight on machine learning, but I want you to think about the fact that there's much more than just machine learning going on. So let's talk about blockchain for a moment, just to digress. Blockchain can optimize complex transactions, whether that's logistics, particularly if your supply chain goes across the Pacific Ocean, maybe to China. You've got this incredible synchrony of things that has to happen between rail and shipping and trucking to get to the retail store, as well as finance, where money's got to go back to China and products have to come back to the United States. Where you have property records. I don't know if any of you have bought real estate recently. I just bought a house about 3 months ago, and the amount of fees necessary to transfer title between houses is significant, or between owners is significant. It seems to me that's an area ripe for disruption. Or capital markets, where today we have what's called T+3 settlement. I sell stock today. It really doesn't land in my portfolio for three business days. Why isn't that instantaneous? Should be the question people are asking. And there are people working on this using things like blockchain. So one of the things to think about is there's up to $300 billion in costs associated with each of these. And this is just one thing. But if we say there's $300 billion in costs, assume that each job is worth $100,000. That means there's 10 jobs per million and 10,000 jobs per billion, which would mean 3 million jobs in each one of these 8 areas that we're talking. 9 million jobs lost in the next 5 to 10 years just due to blockchain. And that's just one area of those 8. So what we're talking about is something that has a set of technologies that have the ability to disrupt the economy. Let's see if I can't make the case a little bit more deeply on machine learning. Machine learning can automate easily any repetitive task. Medicines, where surgery, radiology, and anesthesia are relatively repetitive and easily learned. So one of the areas that we took a look at when I was with NASA iTech was this idea of sending a surgical robot to Mars, because if somebody got injured when they were on Mars, you can't send a surgeon that has all of the necessary skills. But what you can do is send a surgical robot to Mars that has 2 capabilities. One is it has the knowledge programmed into it to perform the surgery. And 2 is that if it doesn't have the knowledge programmed into it, you can send the software instructions to upgrade it. Whereas if you send a human, they can only be a human surgeon who's maybe a general surgeon or some one specialty. They can't have all the specialties. And so you're solving for this idea of the surgical pod can be more skilled across multiple surgical areas than any human can be. And because of this autonomy we talked about with probes, during surgery, you don't have the time for the surgeon back on Earth to give instructions and the surgery pod on Mars to emulate that. You have to have enough intelligence in the surgical pod that it can perform the surgery there in real time. Stock and commodity traders, speculators, brokers, exchanges, clearing services, transportation, Uber, Lyft. Imagine what happens when cars become self-driving. So we can talk about this idea of more than 1 million jobs in each one of those areas. There's actually 3 million truck drivers alone in the United States. And yet people are actively looking at self-driving trucks. So what does that look like for jobs over time? You can go 20 million jobs lost in 5 years, 47% of jobs lost in 20 years. And yet, knowing all that, I'm going to make a prediction that the largest, most expensive purchase you will make in the next 5 to 7 years will be a robot that incorporates most of these technologies. You say, how is that possible? Why would I buy a robot like that? And B, how could it incorporate all of those different technologies? I think it'll be a self-driving car. The registration will be stored in a blockchain. It will be able to drive itself due to big data and machine learning. It will know its location and relative distance to all the other vehicles due to Internet of Things and big data. And it will report its mechanical status and its need for repair utilizing Internet of Things in the cloud. Right? So this is where companies like Tesla are taking us in terms of really, really making your car a lot smarter than it has been historically. So there have been 4 industrial revolutions. The first industrial revolution had to do with mechanical production, railroads, and steam power. The second industrial revolution had to do with the production of electrical power and the event of the assembly line. The third industrial revolution, which was about 1969, had to do with automated production, electronics, and computers. And finally, fourth, we're into this artificial intelligence, big data, robotics, fourth industrial revolution. So you'll read there, many make the case that this time it will be different. It is this assertion we examine in this piece. So this is a quote from Fortune magazine. Here's what I want you to want you to listen for. So if you're listening to CNBC, often they'll be interviewing somebody from Silicon Valley. And when they're asked about this, they'll say, you know, there are all these truck drivers that when you guys do self-driving trucks, 3 million truck drivers are going to lose their jobs. What are they going to do? And they say, the standard party line is, well, they'll be retrained to program computers. And that sounds like a good clip, but, and this is going to sound really horrible of me to say, but the reason they're truck drivers and not computer scientists today is maybe because they don't have the intelligence or the education or the background or the desire to be a computer scientist. And yet the general answer is, well, then they'll become computer scientists, which is just an absurd answer on its face. But I want you to, even if you don't agree with what I'm saying, I want you to listen for that's the general answer. And what that means is that the people who are pushing us down this brave new world really don't have an answer. So I asked ChatGPT what we should expect as far as job loss. And ChatGPT said, according to a report by Goldman Sachs, the workforce in the United States and Europe could be upended if generative AI lives up to its hype. The investment bank estimates 300 million jobs could be lost or diminished by this fast-growing technology. That's from Forbes. By 2030, 45 million Americans could lose their jobs to AI automation, representing about 1/4 of the workforce. That's from Zippia. And automation has the potential to eliminate 73 million jobs by 2030, which would equate to a staggering 46% of current jobs. So I would love it tonight if you could say, oh, Tom, he's just a crazy conspiracy theorist. But I would point out that every statement I make tonight is fact-checked and footnoted. And I'll make this presentation available to you so that you can do your own research. It's on Google, and I'll just share it with Ali and Traverse. And when they send out the video to folks from the call tonight, you guys can go ahead and have access to it. So let's go back to what I said about capitalism a few minutes ago. The definitions we have don't work. Neither more capitalism nor more collectivism work in this environment. Nor does our political system, because voting in people who promise to fix the problem or make the pain go away, but who promise to maintain the status quo, is doomed, right? Because our form of government doesn't work in this environment, and our politicians aren't smart enough to know how to solve the problem. And I'm not saying I am. I'm just saying that when we get to this tipping point that I think will happen in the next 5 years, where people are like, well, there are not enough jobs, and we vote for politicians who say, I will make more jobs. The question is, how are you going to do that in a phase where robots and artificial intelligence make the cheapest, highest quality goods? Are you going to outlaw robots? Because we're going to talk here in a minute about what we call the cheater's dilemma. But the cheater's dilemma, essentially, for those of you, and I'll wait till I get to that slide. We'll come back to that. So here's some thought exercises. Right now, we're in a situation of the Federal Reserve is raising interest rates and has been raising interest rates for about 18 months. Today, if you want to buy a house, you're at about a 7% mortgage. A year and a half ago, if you want to buy a house, you're at about 3.5% mortgage. And yet they say that because they're trying to curb, they're not saying this explicitly, but the fact of the matter is they're trying to actually push people out of work because too many people are employed, the cost of labor is going up too fast. And so if they increase the interest rates enough, then people will be forced out of work and the cost of labor will fall. That's the theory. So if you go back to 2008, they were calling that a jobless recovery, right? We had just gone through this huge blow up in the real estate market, and the stock market came back, and a lot of things came back. But as I showed you on the labor force participation rate came back, the jobs didn't come back, not really. Which begs the question of why, if we're at a 63% labor force and participation rate and 66% has been the historical norm, why the Fed thinks we're at full employment. But that's a longer discussion than we have time tonight. So let me ask you this. Let's pretend for a minute that these predictions by Forbes and the World Economic Forum are right, and that over the next 5 years, we're going to lose 20 million jobs. What would they have to cut interest rates to create 20 million new jobs? I don't have an answer for you on that. I don't even think there is a number low enough, but that's really what they're facing sort of in the near term. So going back to what we said earlier, there were 135 million full-time employees in the United States. And losing 40 million or 20 million of those jobs would represent about an 18% unemployment rate, or increase in unemployment is a better way of saying it. So if no amount of quantitative easing corrects for that kind of job disruption, let me ask you this. What I've showed you from Forbes, from Statista, from the World Economic Forum is not a secret. So as far as people seeking election, whether it's on the left-hand side of the aisle or the right-hand side of the aisle, whether it's Joe Biden or Donald Trump or Governor DeSantis, independent of what side of the aisle on, have you heard any of them propose any public policy that addresses what's going on and what's likely to go on with job dislocation or changes to our economic system that address something like 90% unemployment or outlaws automation until such changes can be made? Have you heard of anybody talk about this in any meaningful way where they're like, look, we've got to do some things because this is going to have profound impacts on our society and we are currently unprepared? And I think the answer to that is no, not whether you're on the left or the right. I don't think people are talking about this properly. And yes, Charlene, you're right. A smart home could fit that description. So let me tell you a story about Paul and Pro and Prabu and Pedro. The good news for American tax base is it doesn't matter where the most efficient robots are. So manufacturing is likely to flood back to the United States, removing transportation costs of raw materials and finished goods and lower energy costs, which means that the end price of goods should fall significantly, but that won't create many jobs. So they're talking about this idea of the CHIPS Act, where we're going to start manufacturing semiconductors in the United States. Or if you heard just today, company Piedmont that makes lithium for batteries for electric vehicles just got permitted to build a lithium plant in Tennessee. But whether you're talking about a semiconductor fab or whether you're talking about a lithium plant to process lithium to make batteries, these are highly automated plants that won't create that many jobs. But they do require, the jobs that they do create are highly skilled, and that is an advantage in the United States of the significant training of the US education system, which means many of the gains made in China, India, and Mexico are sort of worthless because their education systems still don't compete. So when we talk about Poe and Prabu and Pedro, or when we talk about that radiologist who is reading radiology x-rays in India, Prabu goes out of a job not because x-ray reading comes back to some radiologist in the United States. Prabu loses his job because x-ray reading comes back to some computer in the United States. So our laws, our regulation, our education system aren't currently keeping up. So what if in the new system, the best mode was to get some specialized training that was current and relevant now, and it would take you 2 years to get that certificate or that diploma or that training, 2 years to master that information, and it would be good for about 5 years and then obsolete. And what if you needed to spend 2 out of every 7 years in school for the rest of your life just to stay current? Does our current education system provide for that? Is it funded? How could you do that, right? these are the questions I ask about, sort of, I mentioned earlier about, I'm on the backside of my career, but I'm talking about for my kids. And when the best 10% can provide for 100% of the needs of the people, why would you ever go to a provider who isn't at the top? So let me give you an example of that. When was the last time you used Yahoo or Bing as a search engine? Those are number one or number two and number three in terms of search results. Does anybody know who number two is or number three is? And the answer is it doesn't really matter, because everybody uses Google, and number two and number three are so far in second and third place. They're so far back, you can't even see them in the rearview mirror. Well, what happens when that's true of educators and stock traders and surgeons? What do the other 90% do? So let me give you an example of that. If I'm an educator, if I'm the best person in the country and I teach it, I'm going to pick a name, Harvard, and I teach law at Harvard, okay? And I can put my lectures online, and I can teach thousands of people online because of my recorded lectures. Why would you ever go to Regent University to hear from a lawyer like that, who's, I'm sure, perfectly good? He's just not the best. Or if you could have the best surgeon in the world perform your whatever surgery you needed to have done, and he could do that through Intuitive Surgical's Da Vinci robotic surgery anywhere in the world. That dude could be in Colorado and you could be in New York or Virginia Beach, and he could do the surgery from Colorado, and it would be done with the same skill and precision. Why would you go to anybody else? And then once he could train his skills into the Da Vinci robotic surgery suite, and he didn't even have to be there, but now essentially everybody who was getting that surgery was getting worked on by the guy who was the best. If you're the 274th best at whatever that happens to be, who's going to go to that guy or that girl? Stock traders, same way. And same way, it becomes an increasingly a winner-take-all sort of environment. So what are the kinds of jobs that are durable in an AI environment, or in a blockchain environment, or in any one of these environments where a technology is threatening a whole set of jobs? So you don't want to be in a situation where you are doing repetitive, unskilled things. You want to be doing things that are more creative, in my estimation. So, and I think you heard about this. I don't know if you realize it, but the screenwriters are currently on strike, and the actors just went on strike. And one of the big pieces of contention with the screenwriters was, you're not allowed to use ChatGPT to create scripts. You're not allowed to use AI to create scripts, because they realize if they don't win that at the collective bargaining table, it's cheaper, better, faster to use ChatGPT to create scripts for your next great movie. And then they're out of a job. This is a big deal. And this is sort of at the cutting edge of it. So pay close attention to how the screenwriters strike is finally settled, because it's going to have huge ramifications. But people who build platforms, people who make blockchains, people who collaborate at the enterprise level, these are people where the jobs and it will be durable and hard to replace with AI. So William Ellsworth said, prices have never fallen. That is a myth. What's more highly skilled than robots? So William, let me ask you, or let me point a couple things out to you. So when you say prices have never fallen, I would say that the price of computing has fallen. Computers in general have gotten more expensive because they've become much, much, much more powerful. But if you were to try and buy a computer today that had the power of a computer, say from 20 years ago, you can buy a computer like that and a greeting card that plays Happy Birthday, and you'll throw it away, and you'll have bought that computer for about $1.25. So the price of computing has absolutely fallen. But let's talk even more about something where you'd think, well, the price has gone up, like real estate. Your house today is worth more than your house was yesterday, or at least 5 years ago, 10 years ago. And that's generally true on an absolute dollar for dollar basis. I'm currently talking to you in a house from a house that I bought 35 years ago for $67,000, and today it's worth a little bit less than $300,000. It's gone up 500% in 35 years. But the issue is, will that $300,000 buy me any more today in terms of products, goods, and services than the $67,000 would have bought me 30 years ago? And the answer to that is probably no, or it's maybe a push. And what people generally don't take into account when they say, well, I bought a house for $67,000 and I could sell it for $300,000, so I made $230,000, is they don't take into account the effect of inflation on $67,000. And so even in terms of real terms, you could make the argument that things have decreased in price. As far as what's more highly skilled than robots, maybe we can have that discussion after. But the answer to that is robots don't necessarily always have to take the same form factor, that is sort of 2 arms and 2 legs and so on. But there's a lot of things that would qualify as a robot today that you wouldn't even think are a robot. So let's take that toward the end. So one of the things that I've found using AI recently is that where people can be more successful or less successful with something like ChatGPT is learning how to write a great prompt, or learning how to design chips, or learning how to operate fabs. Let's talk for a moment about writing great prompts. If I know how to ask the AI the question a very specific way, I'm going to get much better answer than if I ask a question a different way. And people who know how to ask great questions are going to be highly sought after, in my opinion. So people, creators of expert systems, pioneers of new types of surgery, not people who are doing the routine, well understood surgery, but people who are doing new types of surgery. Jobs requiring a physical presence. So here's what's interesting. The radiology job might get outsourced to AI, the radiologist that of reading the x-ray, but the person who sets the person up in front of the x-ray machine and positions them and puts the shielding in and so on, that's harder to do with a robot or AI. So the jobs requiring a physical presence, nurses, occupational therapists, speech therapists, electricians, plumbers, those jobs are likely to be more durable. Jobs with deep creative aspects, televisions, movies, authors. That last one, authors, maybe not so much. I'll tell you a story here in a few minutes. Jobs with deeply specialized knowledge that's not economic to automate. That is movie or television, lighting technicians, people who have to crawl up in the air, up in the overhead, and they have to hang lights and hang microphones. People who are doing editing where there's a creative aspect to it, or sound design. Jobs that are highly dependent on human action, sales and ministry. These are jobs that are likely to be more durable. So let's talk about the prisoner's dilemma for a moment. So there's 3 people that get arrested. If they all stay silent, the police don't have enough evidence to convict any of them. So their best strategy is for none of them to talk. The second best strategy is to be the first to talk, because the second best strategy says, I'm going to get a deal from the DA, and my other 2 co-criminals, they're going to go to prison, and I'm going to get the deal. So the best strategy is nobody to talk, but because somebody's going to talk, your second best strategy is to be the first person to talk. Right? This is known as the prisoner's dilemma. There's something similar to that, which is it is in everybody's best interest. Remember when I showed you the Boston Consulting Group, where there was a 25% chance where it ends up good for humanity and a 75% chance that maybe it doesn't end up so good for humanity? That's your best strategy. Let's stop and figure out how to do this to avoid the 75% outcomes and focus on the 25% outcomes. How can we make AI and computers and all these new wonderful technologies have the best possible outcome for humans? But since we know that people won't stop, We know China won't stop. We know India won't stop. We know we won't stop. Your second best strategy is to be the first to develop the most powerful superintelligence. Right? This is sort of like the prisoner's dilemma, but we call it the cheater's dilemma, right? Where your best option is to not cheat, but since somebody's going to be cheat, your best option is to be the best cheater, the first to cheat. So then the question becomes, how have I used it? And where can I use it? Being you, how could you use it, right? So about a month ago, getting ready for this talk, I wrote a novel using ChatGPT and a program called AIPRM. And while we're talking tonight, if you want to look up AIPRM and ChatGPT, I wrote a book. I asked ChatGPT to write a book, and I wrote the prompts of what I wanted the book to be about. And I wrote the Quest for Edenaria, which is 40 pages long in 6 hours. It's not very good, but the technology is promising. And maybe 5 years from now, maybe 2 years from now, a non-author such as myself can sit down and crank out a 400-page novel in 6 hours and perhaps get paid for it, right? Oh, and by the way, I used Adobe's Firefly to create the cover art for it. This is completely AI generated. And I wrote a letter of complaint to Delta Airlines using ChatGPT. And I wrote a marketing description for my Airbnb rental using ChatGPT. And I wrote a cover letter for a job application using AIPRM for ChatGPT. These are things that I hoped would be things that people in the audience tonight would be interested in, not to hear about, but to do, to use. Because the next step is to not hear about this terrifying potential future, but to get involved and understand really what the real world capabilities are today, and think about, okay, so if it could do that today, what are the capabilities 5 years from now? If it's easy, like literally that cover letter took 30 seconds. I uploaded the job description. I said, write me a cover letter for this job description. This took less than 30 seconds. Here's the description of my property. Write me a Airbnb. And it wrote me like 2.5 pages. And I said, okay, now condense that down to less than 500 words. So it took me two prompts to write. In this particular case, I uploaded some bullet points of what I wanted to complain to Delta about, and it wrote it for me in literally less than a minute.